Alrighty, so we're getting into the sum and difference formulas and basically how we can use these formulas to, help us simplify some expressions. So you've got these basic examples over here, which, just kind of get you started in how to evaluate and find the exact values for a given angle. And usually, these might be angles that you do not see in your unit circle. And so, maybe breaking those angles down into, basically finding those angles that you have in the unit circle to help you simplify, we can kind of break down into these sum and difference formula. So you've got one example here where we're using a radian measurement for our angle. And you've got a second example here where they do the same thing, but with degree measurement. So, obviously you would see that the rule works out similarly in both of those. So I thought we could work on one example here from our textbook. And let's take a look at number 23 maybe. And the instructions here actually talk about how we can use this to find the exact values for sine, cosine, and tangent. But, again, just in the saving of time kind of sense, we'll do one of those trigonometric functions instead of trying to do, all three of them. So let's do number 23. And how about we pick up, I don't know, we'll do the cosine function here. So this is the angle that we are given, negative 5 pi over 12. Now, like I said, this is not going to be an angle you are going to find on your unit circle because, obviously we don't do the 12th as a denominator here. So the idea is how can we break this down into two angles, which can be part of the unit circle and still help us find the exact value. So for 23, we're only going to focus on cosine of negative 5 pi over 12, but you can definitely use these techniques for the sine and the tangent function also. So the first question comes out to be, okay, how do we want to break down the negative 5 pi over 12 in such a way that we can use, not that one, we can use these unit circles or the angles on the unit circle. So I'll kind of try and bring this guy a little bit over here. So as you can see, mainly we have denominators of 6, 4, and 3 in those angles with the unit circle. And, of course, you have the pi halves and the 3 pi halves. So, again, you're using basic algebra techniques over here to try and break this down. So maybe one of the easiest things would be to think about, breaking that denominator down maybe into 4 and 3. You can obviously try 6 and 2 also because all of those, obviously multiply to give us 12. But I think we're going to try out with 4 and 3 first, and we'll see how that breaks down. So let's take our 12 and break it down into 4 times 3. And the idea is finding a combination which would add up to give us negative 5 pi on the numerator. So I'll give you guys a second to kind of think about this. And remember, this is a negative angle. So, whatever you break it down into, make sure that will add or subtract into a negative 5 pi over 12. So how can we rewrite into something with a denominator of 4 and something with a denominator of 2? And remember, since you're using the sum and difference formulas, you're either going to be adding these numbers or subtracting these numbers. And since it's a negative angle, it basically means you would be going in the clockwise direction, right? Instead of counterclockwise. And if that combination doesn't work, try something else. Because I'm just kind of spitballing ideas over here. So if that doesn't work, what other combination can we go with? Okay, I'm actually going to move this over to our notepad over here. I think it might be a little bit easier. So let's see, this is 23. We want to break down cosine of negative 5 pi over 12. First thing we are doing is trying to split up 5 pi over 12 using our angles from the unit circle. Okay, let's start out with one of the angles being pi over 4. And for now, let's say we want it to be negative because we want the angles to be a negative pi over 4. What other angles should we have over here so that when we add or subtract, we will end up with negative 5 pi over 12? Okay, Darren, you've got negative pi over 6. Let's try that. I'm going to close this guy out. So you are doing negative pi over 6. Okay, and I'm actually going to put that negative here because we'll take this as you're subtracting the two angles. So just a quick calculation over here. To find a common denominator, again, we want that denominator to be 12. So you can multiply this guy by 2. Multiply this guy by 3, and you will end up with negative 3 pi over 12 minus 2 pi over 12, which will add up to negative 5 pi over 12. So you can see that will definitely work out. And in this case, instead of 3, our denominator was 6. So like I said, you just kind of have to play around with different numbers and see what's going to work out. So that is what we will need to break this down into. So when you rewrite, and think of this as scratch work. So you can actually rewrite this guy now as cosine, and then we'll split up that negative 5 pi over 12 into negative pi over 4, minus pi over 6. Once you split that angle up, not this one. So this is cosine, and you are subtracting the two angles. So you will actually use that cosine of u minus v as your rule. So let's go ahead and write that down. So that is going to be cosine of u minus v, which is going to be cosine of u, cosine of v, and this one actually has a plus sign in the middle. So if you just do the comparison between the two cosine formulas, and then sine of u times sine of v. Okay, so this is the rule we are going to be using. Okay, so coming back to our problem, we have cosine of negative pi over 4 minus pi over 6. So cosine of u will of course become cosine of negative pi over 4. Now, when we do cosine of v, is that going to be negative pi over 6, or is it going to be positive pi over 6?
Positive, right?
Yeah, it's actually going to be positive because that minus sign is technically acting as a subtraction and not as a negative on the angle. So you will actually have a positive pi over 6 here. And then of course, plus then sine of u will be negative pi over 4, sine of v positive pi over 6, okay? And now, like I said, since these are the angles that you can find in your unit circle, you can get your values from there. let's see if I can kind of move this here. So can you tell me for cosine of negative pi over 4, what will, or basically for pi over 4, negative pi over 4, what our cosine and sine values will be? Because remember, if you're talking about negative, that means you're going in this direction. So where is your negative pi over 4 going to fall?
Is it 7 pi over 4?
Yeah, very nice. Exactly. Savannah, yeah, very good. So this is your same thing as negative pi over 4. So remember, the first one is cosine, the second one is sine. So that's the value you're going to use. So square root of 2 over 2 for cosine, negative square root of 2 over 2 for sine. Okay, so square root of 2 over 2 for this guy. And negative square root of 2 over 2 for this guy. All right, now you've got the positive pi over 6, and same thing, we'll do sine and cosine for that. Come on. So positive pi over 6, your cosine will be square root of 3 over 2, and of course, sine will be 1/2. So square root of 3 over 2 and 1/2, and then you're literally just cleaning this up. So on the numerator over here, I'm trying to see, do I want to multiply that or do I want to leave it? I think I'm going to leave it as it is for now. So I'll just leave it as square root of 2 times square root of 3 over 4. You have a plus sign here and a minus sign here. So remember, when you have two signs next to each other, there's no number in between the plus or the minus sign, you end up multiplying them. So positive times negative will be negative. And let's see, what will that become? Square root of 2 over 4. I'm trying to actually think what WebAssign wants from you here. Does it want us to factor out? Because, technically you could have square root of 6 over 4 minus square root of 4 minus square root of 2 over 4, which you can then combine, over a common denominator. So I'm not sure if they want you to do it like this, or do they want you to factor out that square root of 2 over 4? And I'm going to show you that over here. So this factor here will of course be common with this factor here. So we can bring that outside, which will leave you behind with square root of 3 minus 1. So I will let you guys play around in WebAssign and see which format do they want. If they accept this guy, then of course you're good to go. If they want you to factor it, then this is what it would end up looking like. So factor out what's common, and then whatever's left behind will go inside the parentheses.
When I was doing it, it accepted the first way.
The square root of 6 minus square root of 2 over 4?
Yeah.
Okay, alrighty. So Lucy tells us that this will be acceptable. There you go then. And but that's pretty much the idea behind finding those exact values. So the biggest part is going to be, seeing how you want to split up your angle. And remember, there's multiple different ways you can do it, guys. This is just one way that I'm showing you. Once you have that split taken care of for your angle, then you're basically bringing in these formulas to help you simplify your answer. So let's take a look at another example here. This one's a little bit different because here they're actually giving you, okay, so they're still asking us to find the exact value of sine of u plus v, where they're telling you sine of u is 4/5 and it falls into the first quadrant. And then they're telling you cosine of v is negative 12 over 13, and that actually falls into, what is that, the second quadrant? So they're giving you one of the values, and then they're telling you which quadrant that angle is going to fall into. So based on that, you can actually then find, you know, the cosine of u and the sine of v by using, you know, right triangle trigonometry. So since we know that sine of u is 4/5 and that's in the first quadrant, well, you can see by using that 4/5, you know, opposite over hypotenuse, you can go ahead and create that triangle in the first quadrant. Based on that, you can find the missing side. So your cosine for angle u will, you know, of course, come out to be adjacent over hypotenuse, which is going to be the 3/5. And that's where your cosine of 3/5 came up from. In that same way, come on, buddy, not what I was doing. In that same way, when you are given cosine of v, and we know this is in the second quadrant, you can go ahead and find sine of v. So again, if this is second quadrant, cosine is -12/13, you know, that would be adjacent over hypotenuse. Using that, you can find the missing side, which of course comes out to be 5. And then using the sine function, that would be opposite over hypotenuse, you would end up with 5/12. And remember, the sine value is positive in the second quadrant. So that's why this guy ends up becoming a positive 5/12. So using that, you now have sine of u, cosine of u, sine of v, and cosine of v. And then, you know, of course, we can just plug that into our little formula, and you are able to evaluate the exact value. So let's take a look at an example for this guy, just to make sure we're comfortable doing this. There we go. Hold on a second, I just realized I did not. Make sure I do that before I forget. Okay, 47 is what we're looking at here. Okay, and the reason I picked secant was just to kind of show you, you know, again, if you don't have those 6 known functions, what to do if you have something like, you know, cosecant, cotangent, secant, how you would go about solving this. So again, I'm actually going to move this guy over to our notepad here. So you are given secant of v minus u. So they're changing that order on us a little bit. And then let's write down what we know. So we know sine of u is equal to -3/5. And this is in, what is that, quadrant 4? 3 pi halves and between 2 pi. We also know cosine of v is 15/17. And here, our v is given in the first quadrant, 0, v, and pi halves. So this is the known information that we have. So based on that, you know, we should be able to do our little triangles for both of them. So sine of u is -3/5, and that's in quadrant 4. So let's see. Quadrant 4. We can do our triangle kind of like this. This will be u. So sine is, you know, opposite over hypotenuse. So we will need to find this side here. And then for cosine of v, we are given quadrant 1. So that angle will actually look, or triangle, I guess, will look something like this. And this is going to be v, and that's cosine. So that's adjacent over hypotenuse. So we'll need to find the other missing side. So can you tell me for the angle u, what our missing side is going to look like?
Is it 4?
Very good. Did anybody else get that? So, you know, this guy is going to be, let's get rid of him. And I'll use a different color here. So your hypotenuse is 5. So remember how you do 5 squared minus, and then you would do -3 squared, and then you would take a square root on that. So basically you would end up with 25 minus 9, which would give you 16, and square root of 16 would actually end up giving you 4. All right, very nice, Lucy. In that same way, we will be simplifying the V triangle and try and find that missing side. So remember, you're basically using the Pythagorean theorem over here. So what will you get for the missing side here? And again, remember, this is where your 90-degree angle is. Alrighty, Andrew, very nice. Yes, so you will do 17 squared minus 15 squared, and then take a square root on that. So you end up with 64. And then square root of 64 is going to be 8. So what that tells you then is, we know that sine of u is -3/5. So now that we have the triangle completed, we can go ahead and calculate cosine of u. And then same thing, you have cosine of v. You have the triangle completed. So now you can go ahead and find out what your sine of v is going to be. So can you tell me what cosine of u is? And what is a sine of v going to be? Hey, come on, guys. It shouldn't take you that long. All right, let's see. Lucy, you've got sine of v as 8/17. Very good. Opposite over hypotenuse. And Andrew, you have cosine of u as 4/5. Yeah, that's okay. Yeah, very good. So for u, it's going to be adjacent over hypotenuse. So that will come out to be 4/5. So that's kind of where, you want to use these little triangles to help you out. Alrighty, so as you can see, for the secant function, we will actually have to use the reciprocal identity and rewrite that secant as 1 over cosine. And then on the denominator, we will be able to use that formula. So let's go back over here. So again, remember, we are doing cosine of v minus u. So we will need to, switch these around. So that's going to be v minus u. So this will become v and u, which I guess since you're multiplying, it wouldn't make a whole lot of difference. But, obviously we still want to maintain that order. Okay, so let's go ahead and write this down. Alrighty, so this will then become cosine of v multiplied by cosine of u. Remember, with the cosine function, if it's minus here, then it's a plus sign here. And then this will be sine of v multiplied with sine of u. So 1 over, let's see, cosine of v was 15/17. And we're multiplying that with cosine of u, which we just found out to be 4/5, plus sine of v. Let's see, sine of v, we found that out to be 8/17. And then, of course, sine of u was given to us as -3/5. Okay, so of course, you will need to then go ahead and clean up your denominator here. So 1 over Let's see if you can simplify something. Should we simplify or for now leave it as it is? Maybe leave it as it is so that we can kind of get our denominators to match and we wouldn't have to find a common denominator because, you know, both sides you're multiplying 17 with 5. So we can leave it as it is for now. So of course, 15 times 4 will give us 60. 17 times 5 will be 85. Again, guys, you have a plus sign in the middle here, but then you have a minus sign coming from that 3/5. So positive times negative will actually end up multiplying and you'll get a negative over here. Of course, 8 times 3 is 24. 17 times 5, as we just saw, is going to be 85. So like I said, if we keep those denominators the same and don't reduce it, it will help us in simplifying that fraction. And of course, 60 minus 24 will be what, 40, 36 over 85. And then remember again, your basic algebra, you keep the 1 as it is, change that division to multiplication, and you invert the denominator fraction. And we end up with 85 over 36. Are we able to reduce that anymore? Doesn't look like it. Yeah, because, you know, obviously, as you saw, 85 breaks down into 17 and 5. And neither 17 nor 5 will go into 36. So we'll not be able to break this down anymore. So that will be the answer you're looking for. So that's our exact answer that we were trying to find for secant of v minus u, you know, based on the conditions. Now, some of these examples, you will see where they may keep the quadrant as the same quadrant. So you can see here, they're telling us both u and v are in quadrant 3, or you can have examples like this where they were, you know, in 2 different quadrants. So you just kind of have to figure out, you know, based on the type of question you are given, but your process is still going to be the same. So question on this one here, guys? Okay. Let's look at one more example here. So this one's a little bit different where they're actually bringing in those inverse trigonometric functions. So you can see how we've got cosine of arctangent 1 plus arc cosine of x, and they're saying write this as an algebraic expression. So you are actually going from, you know, this expression to rewriting it something like this. And this is going to happen again with the help of right triangle trigonometry over here. So how this problem starts out is, you know, you're given the expression. Hold on. Let's put that down to play. So this is the expression you are given. So of course you can see we can rewrite this as angle u, this as angle v. So you've got u equals arctangent of 1 and v equals arc cosine of x. So remember from here, you can rewrite it as tangent of u equals 1, or you can write it as 1 over 1. So that will be, you know, opposite over adjacent. For the arc cosine of x, you can write this as cosine of v equals x over 1, which again, cosine is adjacent over hypotenuse. So you can see now with the tangent function, you have u, tangent of u equals 1. So that's 1 over 1. So that's your opposite over adjacent. And then, you know, obviously using the Pythagorean theorem, you are able to find the missing side, the hypotenuse. With the cosine of v, we know it's adjacent over hypotenuse. So obviously you can see by using the Pythagorean theorem, we're able to find the missing side. Once you get your triangles taken care of, then it's just a matter of, you know, using the formula. So you've got u and v for the arc tangent and arc cosine. So that's cosine of u, cosine of v minus sine of u multiplied with sine of v. And, basically at this point, you're really not interested in these inverse functions anymore because they have solved their purpose. So you're literally looking at what is cosine of u? Well, cosine of u is going to be adjacent over hypotenuse. So that's where this fraction comes from. Cosine of v, that's going to come from here. So cosine of v is going to be x over 1. So, x over 1 just becomes x. So that's where that guy comes from. Minus, that's the minus sign. Then sine of u. So back to the left-hand side triangle, sine of u will be opposite over hypotenuse. So again, that's where this fraction comes from. And then sine of v, opposite over hypotenuse, that's where this guy comes from. And then literally, once you have that, you're just cleaning this up. So you can see 1 times x is x, 1 times the square root of 1 minus x squared, and then both of them will have a denominator of square root of 2. You may be able to leave your answer in this format, or if they ask you to rationalize the denominator, then this is what you will have to do. So again, that's kind of where you are using the sum and difference formulas along with the right triangle trigonometry to simplify this. So let's look at 57 over here. And again, I'm actually going to move this to our notebook. Let's see, so we are given cosine of arc, cosine of x plus arc sine of x. Okay, so again, guys, remember, we're going to assign this guy as u and this guy as v. So you will basically have u equals arc cosine of x and v equals arc sine of x. So again, using the inverse trigonometric function rule, you can rewrite this guy as sine of v equals x over 1. For angle u, you will have cosine of u equals x over 1. So remember, cosine is adjacent over hypotenuse, and of course, sine is opposite over hypotenuse. So we'll again do our little triangles over here. Make it look a little bit more like a triangle. There we go. So this is angle u, angle v. So angle u, you are given cosine. So that's adjacent over hypotenuse. So we'll need to find the missing side here. And angle v, we are given sine. So that's opposite over hypotenuse. And we'll need to find this missing side here. So what do you think those numbers will come out to be? For each of those triangles, what will our missing side look like? Square root of 1 minus x squared for both. Yeah, very nice. Square root of 1 minus x squared. Very good. Yeah, so 1 minus x squared, and you do a square root. 1 minus, and the reason that happened was because you had the same value, x over 1 and x over 1 for both cosine and sine, and the math is very similar. So yeah, you do end up with square root of 1 minus x squared. Okay, so now we have cosine of u. Based on that, we can calculate sine of u for this one. So sine, of course, is going to be opposite over hypotenuse, which will, of course, just come out to be square root of 1 minus x squared. Since you were given sine of v, we will need to find cosine of v for this guy. So that will be adjacent over hypotenuse, which as you will see again comes out to be the same value as the other one. Alrighty, so now the formula we will use is cosine of u plus v. So cosine of u plus v is what we need to use. So that will be cosine of u, cosine of v. Since this is a plus sign, you will have a minus over here, and this will become sine of u, sine of v. And very quickly, I'll show you that over here. So that's the formula we're using. Okay, now let's translate that into our actual problem. So arc cosine of x and arc sine of x. So when you break this down, this will become cosine of arc cosine of x, cosine of arc sine of x, and then minus sine of arc cosine of x, sine of arc sine of x. And like I showed you before, if it helps, think of this as UV. So cosine of u, cosine of v, sine of u, sine of v, and we already have all four of these values. So cosine of u is x over 1, or basically just x. Cosine of v, we just simplified that, which was our square root of 1 minus x squared. Minus sine of u, we calculated that also as square root of 1 minus x squared. And sine of v was x over 1, which will of course simplify into an x. So what do you think this answer will come out to be?
Zero?
Yeah, very nice. Because you have x times the square root of 1 minus x squared, and same thing on the right-hand side, x times square root of 1 minus x squared. So, you're literally subtracting the same value, and it comes out to be 0 in this case. So very interesting example, but, at least it still shows you the steps that are involved in solving an example like this. So questions with this one, guys? Okay. So, they kind of continue the same process, and they've got a couple different examples more for you to look through. So here they're kind of using the idea of the sum and difference formula to help you verify identity. So, you are given cosine of pi halves minus x, and they're asking you to verify that it will in fact give you sine of x. So, again, they're using the u minus v property here. So cosine of u, cosine of v, plus sine of u, sine of v. So cosine of pi halves, you can get that from your unit circle, because you can see with cosine of pi halves, cosine is 0, sine is 1. So when you use that over here, cosine of pi halves gives you 0, sine of pi halves gives you 1. Since this is the generic cosine of x, sine of x, you can't substitute that, but you will see 0 times anything will end up becoming 0. And then you're just left with 1 times sine of x, which comes out to be sine of x. And, we can say, yeah, we verified the identity. So in this one, you're not really solving for an answer. You're just verifying the identity here. So you've got another example with that. This is the same thing. That's kind of happening here is we're using the sum and difference formulas to what they're calling as reduction formula. So you're trying to derive that. So the idea here is we're trying to show, that cosine of theta minus 3 pi halves can be rewritten as just with theta. as the angle. You know, you're basically trying to find a way to get rid of that 3 pi halves. So look at how we're able to simplify this. Same thing, we're using cosine of u minus v. So that's cosine of u, cosine of v, plus sine of u, sine of v. So cosine of theta and sine of theta, again, we cannot break them down, so they stay as it is. Cosine of 3 pi halves is again going to be 0 because that's the 270-degree angle. Sine of 3 pi halves will give you -1. So again, this is multiplied by 0, that disappears, and you end up leaving, or what's left behind is negative sine of theta. So this one here is just talking about how you can rewrite this with the reduction formula, where we can say, you know, cosine of theta minus pi halves is 3 pi halves is the same thing as negative sine over pi. So how do you rewrite that? Same thing with tangent of pi, theta plus 3 pi. You can kind of see we use that same formula, you know, the sum and difference formula for tangent of u plus v. And again, you know, breaking that down, we are able to show that this guy will actually be the same as just tangent of theta. So just different ways of using the sum and difference formula over here. This one is very similar to actually the first example that we had done. The only difference is now, instead of keeping it as sine of, you know, one angle, they are doing sine of x plus pi halves and sine of x minus pi halves. So what's going to happen is you're actually going to use sine of u plus v formula for that first part and sine of u minus v, because you know your angles are the same. They're both x and they're both pi halves. You just have a plus sign here and a minus sign here. So you will see for this first part, this is coming from sine of u plus v formula, and then this is coming from sine of u minus v formula. So the first thing you're actually going to do before you even get to the solving part of it is clean up what you can. So again, cosine of pi over 4, sine of pi over 4 is what we have over here. So again, go back to your unit circle, and you can see for pi over 4, you end up with square root of 2 over 2 and square root of 2 over 2 for both sine and cosine. So what will happen over here, which actually we may not even have to make those substitutions, because if you look at cosine x sine of pi over 4 and cosine x sine of pi over 4, you have a positive sign here and a negative sign here. So they will actually end up canceling each other out, leaving you behind with positive sine x cosine pi over 4 and positive sine x cosine pi over 4. So you're doing 1 plus 1, which will give you 2. So you end up with 2 times sine x cosine pi over 4. And now you can start simplifying it. So cosine of pi over 4 will give you square root of 2 over 2. You know, again, remember, we just did this in the last section. Your goal is to try and isolate that sine of x function. So you can start by dividing by 2, you know, and then multiplying by 2 over square root of 2, so that you can get rid of all of these. You're just left behind with sine of x. On the right hand side, the 2 and 2 will cancel out, leaving you with -1 over square root of 2, which is where this guy comes from. Rationalize the denominator and you get sine of x equal to negative square root of 2 over 2. And then remember again, go back to your unit circle. Where do you see the sine of x giving you negative square root of 2 over 2? And you will see that's right over here and right over here, 5 pi over 4 and 7 pi over 4. And you will see those are the 2 answers we came up with. So again, solving a trigonometric equation like we did in section 2.3, but this time they're just, you know, bringing in that sine of u plus v, sine of u minus v formulas in there. You can kind of see a similar example down here. So, you know, just kind of building up on what you did in the previous section. This one over here, guys, was again just to show you in generic terms, again, how you can use this. So I would just say look over this example, but this one again is just highlighting how we can use the sum and difference formulas, to simplify some of these identities, basically, verifying that those identities actually work. So the biggest thing you are working on here is these sum and different formulas and different ways of using them. Now, when you get into the next section, we're actually bringing in a lot of different formulas in here, but the idea is still going to be the same. You either use them to solve or you use them to verify an identity, kind of like we did in 2.4. So over here, remember we talked about those multiple angle problems last time. So we're kind of bringing in some formulas based on the double angle formulas. You've got your half angle formulas. We had also looked at those. Where did it go? Right here. So, where you have 2 times u or u divided by 2. So we call them the multiple angle formulas. Now we're giving them specific names, double angle formulas or half angle formulas. We also have a power reducing formula in here. There's one more. Yeah, and then we have these product to sum and sum to product formula. So just different types of formulas and how you can use them to simplify these expressions. So let's start with our first example over here. And let's see, I've got okay, there we go, section 2.5. So this one here, we're basically being asked to solve an equation and we're going to work on number 9. And as you can see, guys, number 9 here is dealing with these double angle or multiple angle problems in there. So how can we simplify them using, these formulas that we have? Let's save this, and I'm actually going to move this to our notebook. This was number 9. We are given sine of 4x equals -2 sine of 2x. This should actually be a small letter. So let's take a look at how we need to break this down. Okay, so we'll need to, of course, use the double angle formulas over here, but first let's go ahead and clean up our equation here. Okay, so since you have -2 times sine of 2x, let's go ahead and move it to the left-hand side by adding it. So, of course, cancel it out and we'll end up with equal to 0 on that side. Now, this is where we'll introduce our double angle formulas. So let's move this guy a little to the side. And let's see. What we are actually going to end up doing here is with that sine of 4x, we're going to use a little algebra. So, obviously 4 can be broken down into 2 times 2. So I'm actually going to break this down into 2 times 2x. So what's actually going to happen here is, how you have the 2x here? So this 2 is actually going to act like this 2 over here, and then that entire parentheses 2x is actually going to act like the single x over here. So, when you break this down into this formula over here, since we have, and let me get so since you have sine of 4x, we're rewriting that as sine of 2 times 2x. Think of this guy as your 2x. So each one of these will become 2x. So that's kind of how we're going to break this down. Does that make sense? It's a little bit of a trickery, we're going to have to use here to break that down. So this guy will then be rewritten as sine of, sorry, I missed my 2. 2 in the front, and then sine of 2x, cosine of 2x, and remember this is the formula that I'm using, plus for the right-hand side, the 2 times sine of 2x. Do I want to break that down or do I want to leave it as it is? I think for now I'm going to leave it as it is, and I'll tell you why in a second. Let's clear this out. So the reason I'm doing that is because I'm noticing that on the left-hand side, I also have 2 times sine of 2x, so I can actually take those out as our greatest common factor, and that might help us in, simplifying this. So we'll factor that out, 2 times sine of 2x. So on the first part, you will be left behind with this cosine of 2x. Plus, since you took the entire 2 times sine of 2x out, we will use 1 as the placeholder. So we can factor this out into 2 times sine of 2x, and then in parentheses, cosine of 2x plus 1 equals 0. And then remember how we use the 0 factor property to set each one of these factors equal to 0. So you will take 2 times sine of 2x, set that equal to 0, or cosine of 2x plus 1 and set that equal to 0. Now we're going to solve each one of these individually. So let's start out by, I guess, getting rid of this 2, divide both sides by 2. Sine of 2x equals 0. And over here, you basically want to think about, okay, when is my sine function equal to 0 at? So for what values of the angle is sine going to be 0? And, again, you can use your little unit circle for that. So we know sine is 0 at angle 0 and at angle pi. So that's what you're going to get over here is 0 and pi, which, again, what do you think we'll end up getting for x over here when you simplify this?
0 and pi over 2.
Yeah, exactly, because you'll divide each one of these by 2 to get that x by itself, and you'll get 0 pi halves, which, of course, you can think about this with sine function. I guess you will add 2 n pi, or will it be n pi? Well, actually, since it at 0 and pi originally, I guess you can do just n pi, because that'll automatically take care of, at every basically 180 degrees, you're going to have 0 and 0. So that might work out with this. Which basically you're adding n pi to that. So that'll be our x. So that's coming from the sine. And then on the other side, you have cosine. So let's see, start by subtracting the 1. Same thing, we want to try and get our function value. So now think about for what values of the angle is our cosine going to be -1. Where is our cosine function equal to -1 at? There's only one angle where you will have that. Cosine equal to -1. Okay, let's see, I'm seeing something on chat. Yeah, Savannah, very nice, perfect. At pi is where your cosine function is -1. So this will be pi, and then of course, this one you will do 2 n pi because it's only at that one angle. And then same thing, divide everything by 2. And we end up getting pi halves plus n pi. Okay, so those will be your angle measurements. And again, remember guys, that rule still holds. If they ask you for specifically in a given interval, then you don't add the 2n pi. And if they just say, like they said here, solve the equation, you're doing the general solution. So you will add the period of 2n pi. So that's kind of, again, you're using the double angle formula to help you simplify a problem. And you've got, again, examples in here kind of following that same rule of, how you want to solve. So you've actually got a couple different examples that you can look through with how to work with these double angle formulas. The next one I had selected for us was kind of that example that you were just looking at, is how we can use these given conditions to, try and find the exact values for these functions here. So again, to save time a little bit, we'll do number 19, but let's do just for the tangent function and see how we can come up with, this exact value for tangent of 2 times u. So let's take a look at this guy. Okay, so we are given sine of u equals -3/5, and this is given to us in, what is that, quadrant 4? 3 pi halves u 2 pi, and we have to find out tangent of 2 times u. That's what we're trying to solve here. So let's go ahead to our, and this is the example I'm actually working on, just, from our textbook. All right, let's take a look at that tangent formula over here. Okay, so let's write it out. Tangent of 2u is going to be 2 times tangent u over 1 minus tangent square of u. So as you can imagine, again, they're giving us sine of u. They're telling us which quadrant we are going to be in. So this is, again, where you want to use that right triangle trigonometry. And since this is going to be quadrant 4, this is what our triangle will end up looking like. This is going to be angle u. So sine function is going to be opposite over hypotenuse, and we'll of course need to find this missing side. So what do we think that missing side will come out to be? Okay, let's see, Andrew, very nice. So again, you will be doing 5 squared minus -3 squared, which will of course come out to be 25 minus 9, which will give us 16, and square root of 16 will end up giving us 4. So we've got all 3 sides now. And so of course, since you can see in the formula, we need to know what tangent of u is. Remember, tangent is opposite over adjacent. So that would be -3/4. Okay, let's put this into our formula now. So 2 times tangent u, so 2 times -3/4 divided by 1 minus tangent u, and of course the whole thing squared. So -3/4 squared. And I believe just clean it up and we should be good to go. On the numerator, I want to clean this up. I think I do. 2 will go into 4 twice. So you can clean that up, which will end up giving us -3/2 on the numerator. Denominator, we have 1 minus. Now you have -3/4, the whole quantity squared. So remember that square is going to make that inside negative sign turn into a positive, right? 3 times 3 will become, or negative times negative will become positive. 3 times 3 is 9, 4 times 4 will give you 16, and then go ahead and clean up that fraction. So what is 1 minus 9/16 going to give us? And again, you should be able to throw that into a calculator or, use algebra, like find a common denominator. So multiply this guy by 16. Andrew, again, very nice. Yeah. So you will end up with 16 minus 9, which gives you 7 over 16, which again, keep the numerator the same. Change division to multiplication, invert the denominator fraction, and clean that up. 2 goes into itself once, 2 goes into 16 8 times, and let's see what will that give us. Negative 24 over 7. Yeah. And we can't reduce anything down because 7 does not go into 8 or 3. And you can find your exact value. Now, of course, guys, since you already have the triangle taken care of, using the sine 2u and cosine 2u, you should be able to find these values just like we did with the tangent function. But like I said, just to save time, we're just going to do one of these for now. But as you can see, the formula is just helping you guide through the process, but we're still using a lot of those techniques that we learned in chapter 1 actually to help us out here. So questions on this one here, guys? Okay. So this was coming from, again, using the same double angle formula, but how can we use that to actually evaluate a function instead of just, solving an equation? So just a little bit of a different application. So again, you've got a couple different examples here that you can see. I would definitely recommend you guys to look at this example here because this one has 3 times x. We did the 4x example. We, of course, had the 2x in there on the very first example that we did. But I would definitely want you guys to look through the sine of 3x. And then you, of course, have the cosine of 3x example on the bottom just to see, okay, how can these odd numbered problems kind of break down? So you have an idea of how these ones will break down. So our next rule we're getting into are these power reducing formulas. So the power reducing here, as the name suggests, you can see these guys are starting out with, sine to the second power, cosine to the second power, tangent to the second power. But you will see in the formula, they actually break down into just the cosine, and cosine, right? So you're losing the second exponent and you just have one exponent, but now then these guys are turning into cosine of 2u, cosine of 2u for, all of these. So that's kind of how we're reducing the powers down. And remember, you have proofs for all of these different formulas in your textbook. If you were curious to see, how you ended up from sine square of u to 1 minus cosine of 2u divided by 2. So you do have those proofs if you're interested in looking at it. Oh no, kick me out. All right, let's try this again. Okay, and for this one, we are looking at come on, buddy. Okay, so for this one, I thought we would work on the tangent function here using the power reducing formula. So we'll do number 29. So we are given, let's see, tangent to the 4th power of 2x. So let's see how we can break this down. So tangent to the 4th power of 2x and our power reducing formula. So we'll actually have to use, again, a little bit of algebra to simplify this. You can see the power reducing formula actually works with tangent to the 2nd power, right? So that's what we're going to break this down into, is we are actually going to rewrite this as tangent to the 2nd power of 2x. And then, so basically what we're doing, and I'll just show this to you with generic terms. So if you have y to the 4th power, technically you can write it as y squared times y squared, or you can write it as y squared to the second power, because we know 2 times 2 will still end up giving us 4. So that's what we're doing here, is breaking this down into tangent squared of 2x and then putting the square on the outside so that we are able to use the formula over here. So using the formula, we should have 1 minus cosine of 2u and 1 plus cosine of 2u over here. Okay, so you are given tangent squared of 2x in the problem. So when we translate this over here, you will actually end up with 1 minus cosine. Since you have that extra 2 over here, you will actually need to multiply by a 2 in the front. So you will actually end up with 4x and 1 plus cosine of 4x. So again, having to kind of make those changes based on what you are given. So 1 minus cosine of 4x over 1 plus cosine of 4x. And then remember, guys, we still have that second exponent on the outside that we still have to worry about. So making a little bit of a modification, or actually 2 different modifications over here. Now, once you have the 1 minus 4x, 1 minus cosine of 4x and 1 plus cosine of 4x, we will actually now have to use FOIL for both our numerator and denominator. So in this case, let's do it on the side. So you have 1 minus cosine of 4x being multiplied into itself. So that will be 1 times 1. And then 1 times negative cosine of 4x, negative cosine of 4x times 1, and then negative and negative will become positive. Cosine times cosine, so that will become cosine squared of 4x. Pretty much the same thing's going to happen with the denominator with the 1 plus. The difference will be when you make this into a plus, you will end up with 1 plus cosine of 4x plus cosine of 4x plus cosine squared of 4x. And then, of course, for each one of these, you will combine the middle term. So that means we will end up with 1 minus, because cosine minus cosine will become negative 2 cosine of 4x plus cosine squared of 4x. This one will be 1 plus 2 times cosine of 4x plus cosine squared of 4x. So again, combining these 2 terms, this becomes negative 2 cosine 4x. This becomes positive 2 cosine 4x. So you can see we're using rules of exponents. We're using the FOIL property here. So a lot of that algebra is still coming into play. And remember, the idea here is we're talking about using the power reducing formula. So everything should be in terms of the first power. So, we still have this cosine square and cosine square, and that's the part we need to be able to simplify further. So now we're again going to have to go back and use the power reducing formulas for the cosine squared. So let's go ahead and write down what we have. These guys will stay the same. And then for the cosine square of 4x, we will need to use the power reducing formula again, which is going to be this guy here. So we have cosine squared of 4x, which will translate into 1 plus cosine of, let's see, 4 times 2, because again, you have a 4 here, so you will multiply by a 4 here. So 4 times 2 will give you 8x over 2. 1 plus cosine of 8x over 2. So that's what you are bringing in here. So plus 1 plus cosine of 8x over 2 plus 1 plus cosine of 8x over 2. So you can see, guys, you know, it does get a little complicated, and I'm doing this on purpose because you actually have this example in your homework. And this is the one I've seen where students have struggled in the past. So that's why I'm kind of using this one, so that you guys have a pathway. When you see this on homework, you know exactly how to break this down. Now it's literally a matter of just cleaning this up. So let's see, how do we want to do that? We want to get rid of that denominator 2. So I guess multiply everything by 2. So if I multiply everything by 2, what will that give us? Well, remember you distribute that. So that 2 will go into everything. Sorry, not that. Since that's one single fraction. What will that give us? 2 minus 4 cosine of 4x. And where you have that denominator of 2, that will actually cancel out. So this numerator part will actually stay the same. So 2, 4 cosine of 4x plus 1 plus cosine of 8x. And then all you need to do is combine like terms. So this 2 can be combined with that single 1. Same thing on the denominator here. So let's see, 2 plus 1 will be 3 minus 4 cosine of 4x. Oh, I got rid of that one. Cosine of 8x, and denominator 2 plus 1 is 3 plus 4 cosine of 4x plus cosine of 8x. So this is your power reducing formula where we took it from the 4th power on the tangent function, and we basically had to break it down where you did not have any exponent on your trigonometric function at all. It was all going to be in the 1st degree or 1st power. And that's kind of what this breaks down into. So I know it takes a little bit of time to kind of break this down step by step, but be patient, you know, follow these rules, and you will be able to, you know, eventually get to that answer. So questions on this one over here, guys? Just be patient, okay? Alrighty, so this was using our power reducing formula. And again, you've got this example here with the sign to the 4th power. So you can kind of see, you know, when you're using a different rule, how that might look like. So you can again look at this example here to help you out. Now, half angle formulas, of course, you can see in this case, instead of 2 times u or, you know, 4 times u, you have u divided by 2. So for this guy, let's see. Okay, so this one here is asking us to use the half angle formulas. And again, they're asking us to find for all 3 functions, but again, we don't really want to take too much time using all 3 of them. So we've done a couple examples with tangent. Let's do the sine function for this one. So for pi over 8, let's try and break it down into the sine function. And let's see what that guy will come out to be. Okay, so this guy is 37. And we want to find sine of pi over 8. Okay, so let's see what this function looks like. So again, you can see with the formula, you need your denominator to be half or 2, right? So that means we will have to rewrite our angle over here. And so since they are giving you sine of u over 2, think of this as sine of 1/2 times u. And that's kind of the idea we're going to be using over here. So, of course, when you are given 1/8, I can break that down into 1/2 multiplied by 1/4, right? 2 times 4 gives me 8. So I'm going to apply that same technique over here, and I'm going to rewrite my pi over 8 as 1/2 times pi over 4. So the u will actually be pi over 4, and that 1/2 is acting as your denominator of 2 in the formula. So if that helps, think of this as your u. Now, oops, didn't mean to do that. Let's bring in our formula over here. So that is sine of u halves, or sine of 1/2 times u is plus or minus 1 minus cosine u over 2 inside the square root. Okay. 1 minus cosine of u over 2 and the square root. And this is what we want to try and use as our half angle formula. Okay, so plus or minus inside the square root 1 minus cosine of u, and remember our u is the pi over 4 divided by 2. So how can we clean this up, guys? And the other thing, okay, just as a note, you should look at that remark over here. And then they're telling you the signs of your sine of u halves and cosine of 2 u halves will depend on the quadrant in which your u half will lie. So what quadrant are we going to be in? Because we need to decide if we will have a positive or a negative sign over here. Which quadrant do you think our angle pi 8 is falling into? Yeah, Darren, very nice. Perfect. Yes, this is a quadrant 1 angle, because pi 8 is literally half of, this angle over here. So it is going to be quadrant 1. Perfect. So that means since this is a quadrant 1 angle, your sign is going to be positive. So actually, let's just get rid of that plus or minus, because we will have a positive angle here. Okay, so cosine of pi over 4, that is a known angle. Cosine of pi over 4 is going to be square root of 2 over 2. Clean that up and you basically have your answer. So, if you're just working inside the radical for now, basically you have 1 divided by 2. So I'm just separating that. And then square root of 2 over 2, again, you're dividing that by 2, or basically multiplying it by 1/2. And then all of this is under a radical. Now you will kind of have to see again how WebAssign wants you to clean this up. So that will be something, you will have to see, because there's many different ways you can go from here. Trying to see over here, actually. you could find a common denominator, which would give us 2 minus square root of 2 over 2. We still have that 2 on the bottom. Which would actually what? 2 minus square root of 2. Yeah, I think that's what it should clean up into, because over here, again, I can kind of bring out the 1/2 as a common factor. And then you're left with 2 minus square root of 2. So play around with it a little bit, because I'm not sure what WebAssign wants. You know, sometimes they simplify the answers and sometimes not. But that's kind of, again, the idea of using these half angle formulas to help you, come up with the exact value of your function. So again, you can see they've got examples here, if you're working with degree measurements instead of radians, pretty much the process will stay the same. That should be a radical sign there. But you can come up with, your exact answers. Yeah, go ahead.
Can we see that problem which you had again? I was confused where this 1/2 came from. I thought it should be on the bottom right there, right above the red, where it's the 1/2 minus the square root of 2 times 1/2. Shouldn't that be a 2 over 2, because it's divided by 2, which is 2 over 2 instead of.
Oh, okay. So what I did here was, of course, we're taking this 1/2
that
and
one.
this 1/2. Well,
Because the
Yeah, so
1/2
what-
comes from the divided by 2 at the front. But the second part, if you're going to do that, it's 2 over 2, isn't it?
okay. Are you talking about this stage here?
I'm talking right where you are. Yeah, right there. I just don't understand where that second 1/2 is
Okay,
coming
yeah.
from.
So you do end up with 2 over 2 here minus square root of 2 over 2 here. And then we still have this 2 on the bottom. So I'm actually going to take that guy outside as our 1/2. And then all of this is still under our radical. Okay, let me clear this guy out.
It's okay. Let's just go. I know you got it.
So you're fine.
trying to-
And then in this case, what's going to happen is, since these guys are the same denominator here, you are going to end up with 2 minus square root of 2, and then this common denominator of 2, which I will end up multiplying and making this 1/4, and then you're left with 2 minus square root of 2. And then this is where that 1/4, square root of 1 is 1, square root of 4 is 2. So that guy comes outside as your 1/2. And then you're left with 2 minus square root of 2 over here.
Okay. Thank you.
Yeah, so I was just kind of skipping a few steps in there, but that's kind of where, if they accept this answer, you're good to go. But if they don't, then you may have to break it down to this one here. Because, again, WebAssign kind of does its own thing a little bit differently. So you can kind of see the answer you ended up here. If they accepted something like this, then you should be good to go. And if they want you to factor it and simplify it further, then you may have to go with this answer. So it really, I would say, try both of them and see what works. Okay. So again, guys, you've got a couple different examples in that over here that you can work with. You've got some equation solving over here that you can look at. Again, as you can see, this is working with our little cosine squared function. So, we're bringing in those power reducing formulas again. So you take your cosine square and break it down by using the half angle formula. So just different applications that you will be working with. One thing that I did want to show you was you actually have these product to sum formulas and sum to product formulas over here. So I know we're a little bit over our time, but I really just wanted to show you an example on this. At least you knew how to use the formulas. So let's take a look at number 47 over here. So this one, as you can see, is sine of 5 theta, sine of 3 theta. And so as you can see, this is where you will have to use, you're going from a product because we're multiplying the two sine functions into a sum. And this is where our little formula will come into play. Okay. And you actually can go from sum to product or product to sum depending on how the problem is given out to you. That should be a theta. Looking at this formula, of course, you are using that first one, sine of u multiplied by sine of v. And again, look at how this breaks down. So you have 1/2 on the outside, cosine, and you have, think of this as your u and this as your v. So that will become 5 theta plus 3 theta, which of course adds up to 8 theta, and then minus cosine of, again, 5 theta plus 3 theta. So when you clean this up, 1/2 on the outside, we are now doing cosine of, oh, sorry, that should be a minus, not a plus. So 5 theta minus 3 theta will of course be 2 theta minus cosine of 5 plus 3 will be 8 theta. And let's see how far do they want us to go in this. Actually, that's as far as you need to go. So you are converting this from a product to a sum, but it can be a minus sign, sum or difference. If you were to go in the opposite direction, then something like number 55 over here, where you are given a sum and they want you to convert this into a product, or basically find the exact value as they're talking about here. So just very quickly on this guy. So again, looking at the formula here, this is what you have, sine of u plus sine of v. So think of this guy as your u, as your v. And using the formula, we have 2 times sine of 75 plus 15 over 2. And then that's the cosine of u minus v over 2. And since they're asking you to find the exact ones, of course, we will be able to simplify this, because 75 plus 15 will give us what, 90, right? 90 divided by 2.
45.
45, there you go. And then this guy was 75 minus 15, so that's what, 60? 60 divided by 2 will give you 30. And both of these angles are your unit circle angles. So you can see 45 degrees, 30 degrees, you are doing sine of 45 and cosine of 30. So sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. And then go ahead and simplify that, which this will break down into, let's see, one of those 2's will cancel out. And then you're literally left with what? Square root of 2 times square root of 3 will be square root of 6 over 2. And you can solve that example. So, again, all of these formulas are used to help you simplify a problem or to help you find a solution to an equation. So just different ways of how we can work with these multiple angle formulas, double angle, half angle, or if you have to reduce the power from like a 4th degree to just the 1st degree, how you can use these. So all different types of examples that you have in here. So guys, I would definitely recommend you to look at all these examples that are given to you over here, so that way you at least know how to work them with different examples. Now, I will be here tomorrow. I will be here on Friday. So any problem that you get stuck with, you need extra help with, let me know. But at least try and work on these homework assignments through Friday, so that way you have a chance to ask me questions. Even on the weekend, if you get stuck on anything, at least send me an email, and I will definitely try to stay up with the emails if I can on the weekend and try and answer back. If not, I'll definitely try to get back to you guys on Monday. So look through these. Let me know if you have any questions. I'll be glad to hang on a little bit longer and answer any questions that you might have. And I know you said that you needed a little bit of help, I think, Lucy. Was it Lucy or Savannah? I can't remember. Sorry. But whoever needs help, stay back and I'll be happy to answer them. And I will see you guys on Monday for our chapter 2 exam with this. So have a wonderful evening, guys. Thank you for staying a little bit longer so we could wrap this up. Take care and have a wonderful weekend. Be careful, everyone. Stay safe. Thank you.
All right, so my question was just, it's a little bit further back, but in section 2.3, there's exercise 31, which looks like it would be very easy.
Yeah, sometimes it may look easy, but you never know. You said number 31.
Yeah, it's just secant squared x minus 9 secant x equals 0. So like I go through this one and I think I'd be able to do it in like a second, but I think I'm just having an issue with the notation maybe.
So Lucy, you should be able to share your screen with me
Sure.
so I can see what the exact problem looks like.